In example 2, we have two graphs. The first graph is the graph of the function f of x, and the second one the graph of the function g of x. And we have the parts from a to h. We will find the values of the limits from the given graph. Use the graph f and g and the accompanying figure to find the limits that exist. If the limit does not exist, explain why. So we'll start with part A. Part A, we want to find limit f of x plus g of x. This is the function f of x, and when x goes to 2, this is 2. Okay, so limit f of x when x goes to 2 is equal to 0 from the graph, plus limit g of x when x goes to 2, this is 2. So limit g of x when x goes to 2 equals to 0 also, and 0 plus 0 equals to 0. For the second part, in part B, you have to find f of x plus g of x when x goes to 0. So we have different x. When x goes to 0, the limit of f of x does not exist, because this is 0, and here we have 0 from right, and here we have 0 from left. So the limit f of x when x goes to 0 does not exist. So all the limit does not exist. All the limit does not exist. Part C. In part C, limit f of x plus g of x when x goes 0 from right. 0 from right. So 0 from right, this is the function to the right of x equals 0, and hence we have limit f of x when x goes 0 from right is equals to negative 2. Plus limit g of x when x goes 0 from right. Here from right and left we have the same value of the limit, and the limit exists for g of x when x goes to 0. But for the function f of x, we have different case because we have jump when x equals 0. So we have different values of limit from right of 0 and left of 0. In our question, x goes 0 from right, so 0 from right equals to negative 2, plus limit g of x when x goes 0 from right equals to 2. About the function g of x, we have the same limits from right of 0 and left of 0. So we have negative 2 plus 2, which is equals to 0. In part D, we have limit f of x plus g of x when x goes 0 from left. Now 0 from left for the function f of x, the limit is equals to 1, because this is the function to the left of 0, and the limit when x goes to 0 from left equals to 1, plus limit g of x when x goes 0 from left for the second function g of x, also it's equals to 2, and 1 plus 2 equals to 3. For part C, this we can write it as f Okay. Okay. Now part E. Part E, limit f of x divided by 1 plus g of x when x goes to 2. So limit f of x when x goes to 2 from the graph equals to 0. Divided by 1 plus limit g of x, and limit g of x when x goes to 2 equals to 0 also. So we have 1 plus 0, which is equals to 0. Now in part F, this is part F, limit 1 plus g of x divided by f of x when x goes to 2. So we have 1 plus limit g of x when x goes to 2 equals to 0, and also divide by limit f of x, which is equals to 0 when x goes to 2. So we have 1 divided by 0, which is does not exist. In part G, pay attention, we have square root, and it's not allowed to have a negative quantity inside the square root. So the function, the limit is limit x goes to 0 from right for the function f of x under square root. So 0 from right equals to -2. So the answer will be radical or square root of -2, which is undefined. So the limit does not exist for part G. And the last part, which is part H. And in part H, we have the same as part G, but when x goes 0 from left, so we have square root or radical of limit when x goes 0 from left, which is equals to 1. So we have radicals 1, which is equals to 1. And that's it.